Hi everyone. Uh, Hi, I'm Blake Lamont from Billigence. Thanks for joining us this afternoon. Today I'll be discussing, giving you some tips and methods on how to streamline data science initiatives in your organization using Alteryx and Snowflake. Thanks. Probably actually before we get started, just a little bit of background around Billigence, around who we are and what we do. We're a global BI analytics consultancy with offices in Prague, Frankfurt, Singapore, Sydney, London, and San Diego as well. And we work with a wide range of clients across a wide range of initiatives as well. We have 5 pillars focusing upon data consolidation, data governance, predictive modeling, data visualization, and also CRM as well. So we've worked with a wide range of clients in a wide range of industries as well, tackling quite a diverse set of problems and challenges as well. And we use industry-leading technology such as Alteryx and Snowflake. So before we get started, in case you don't have direct experience with Alteryx or Snowflake as well, perhaps a little bit of background around what exactly they are and how they can help you and in your organization as well. So Alteryx is an industry-leading self-service analytics, data prep, data blending, and data science platform. It connects to a very large range of data sources. It features over 260 building blocks or tools that are very intuitive to use and connect in the canvas with a graphical interface. It's very, very useful to automate reporting and support predictive and prescriptive analytics. It's also very, very strong in locational or spatial intelligence as well, and recently released an intelligence suite, which really has lots of very useful tools to support natural language processing, and also has some very useful tools that allow you to embed your R and Python scripts as well. So your data scientists in your organization can really leverage their work, or your organization can leverage their work within the workflows as well. It's a very, very useful, versatile software that I've personally used on quite a number of interesting challenges and projects as well. Also talking about Snowflake as well. So what is Snowflake? It's a fully managed data warehousing platform that combines a new SQL query engine that's natively designed for the cloud as well. So it basically provides the functionality of an extremely fast enterprise analytic database as well, and can run on your cloud platform vendor of choice, either AWS, Azure, or GCP. So there's no hardware to manage or install, no software to install or configure, no maintenance required as well. So some of the innovation is really around the architecture as well, separating storage and compute and services in different layers. And the architecture helps consolidate data warehouses, data marts, data lakes as well. And these independent layers are scalable as well to meet your immediate needs and requirements as well, either on the storage or the compute, and also the services as well. So it's built with heavy usage and very large data sets in mind as well, and offers a lot of secure data sharing as well, and also the Snowflake data marketplace that allows you to easily source and share or source external data, and allows you to share data quite readily and quickly through the data exchange as well. So to be able to track and secure that on a very finite level as well. So what happens when we bring them together? So why do we use them together as well? So they're very, very useful. Alteryx combined with Snowflake, allowing us to connect to a very large number of data sources, very quickly prep and blend the data, inputting and loading onto Snowflake, also extracting back locally as well. We have a large number of components. One ability of Alteryx that I particularly find very useful is the functionality to customize your own tools and macros. for different situations, and collaborate and share them amongst your colleagues across the way as well. Also, the Alteryx server is extremely useful for sharing workflows, published workflows in a secure fashion as well. And it's very, very useful for tackling either ETL problems or smaller data prep problems, spatial, predictive, and prescriptive. We'll get into that a bit more as well. And so another great aspect of Snowflake is that it breaks down the data silos in that you don't have to provision or copy subsets of your data amongst organizations. So you can break down the silos as well. You can really have a single source of truth, a single platform as well, that can then scale up instantly for heavy loads with the computing as well, and also increase the storage as well. So they work really quite well together, and that's what we'll kind of get into a little bit more today as well. Oh, and I forgot to mention the partner ecosystem and the connectors as well with Snowflake as well. So really work together very well. So going through in using learning about Snowflake as well, it's challenged some traditional kind of concepts and methods in business intelligence as well. And so just kind of touching upon the, I guess, kind of more traditional way of processing data as well. So traditionally, you've probably heard of the ETL process as well, which stands for extracting data, transforming data, and then loading it into your database, data warehouse as well. And so this process has worked very well in the past, but involves loading your set from your data sources into a staging area, and then after that performing your transformations, and then finally loading into your consumption layer within the warehouse as well to support analytics or reporting as well. So this developing this transformation process can be quite detailed as well, and it tends to be designed to immediately support your business requirements as well. So if you have daily or weekly reporting, or you need to analyze your data on a specific product basis, there might be some ways. Those are some ways that might influence your design approach in extract, transforming, and loading as well. And so I just wanted to perhaps show you now in Alteryx a very kind of simple version of how we can use this today with Alteryx and Snowflake. So switching across in here, very kind of typical, we have monthly sales reports. So perhaps listing the products on a daily level where we see sales and customers as well. This example is meant to kind of mimic kind of transactional level data as well. The data is stored in separate worksheets. So this might be an example of something that you see amongst your kind of sales team coming out of perhaps a product specific warehouse or external data source as well. So here we can see that the data is separated in each individual sheet. And so this doesn't, as it's in its current form, allow us to analyze trends across months and really drill down as well. However, if I switch over to Alteryx in here, okay, hopefully you can see this. So in here, I'm using the input tool, and I'm bringing in the list of sheet names as well. And then I'm feeding this into the dynamic input tool and specifying a template for one of the sheets, and then giving it the list of sheet names within there as well. And so that will automatically, within Alteryx, import every single sheet found within the workbook and automatically union them. And so that's where I can leverage the consistent structure across the worksheets as well. And so this is really meant to mimic the extract stage in ETL. Now, this in its own isn't particularly useful. I can scroll down, but I don't know what the product types are as well. So then moving on to, I guess, an example of the transform process as well is I take my list of product codes within here. As you can see, down in here, and then I attach them. So using product type. So a very simple join, but enriching the data. So from there, sorting it chronologically within there, and starting to enrich this a little bit further, adding additional fields. So perhaps a sales rep, product manager would like to know, how are my sales on a particular day of the week, or on a monthly level as well. And so I can leverage locally the formula tool in Alteryx to add those days of the week and month, extracting them from the date field. So very simple kind of calculation, but I'm enriching and adding extra features to my initial data set. So that in itself is somewhat more useful, but now I can proceed and I start to aggregate this, particularly by perhaps by product type and day of the week, to see my daily sales. Do I sell more chocolate bars on a Monday, or perhaps on a Saturday? And perhaps more for sales reporting as well. I look at this now, I aggregate this instead on a monthly level. So I'm making a decision here ahead of time before I load, trying to meet business requirements in how I aggregate and enrich this data and add additional features. Then I am loading these very quickly into Snowflake, my trial version instance of Snowflake in here. Now, this is a very small data set, but it's just an example of how quick and easy it is to load your data, your enriched, cleansed, prep data from Alteryx into Snowflake in here. So when I switch back over into my instance in here, I can see I've loaded this data quite quickly and easily. So very small amount of data, but I perform my transforms and then loaded this as well. From here, within Snowflake, I could connect this to my reporting platform, either Tableau, Power BI, or output this as a CSV. But I've locked in these views as well. So quite quick, quite easy to achieve in using Alteryx and Snowflake as well. I have this on a very small sized warehouse at the moment, but using Snowflake, I can very quickly scale this up or resize my warehouse and dedicate more computing resources to this, or more storage based upon the volume of data as well. So the alternative approach, and what's becoming more useful in some situations, is extracting your data, then loading it into your cloud platform. So when you have large volumes, loading them into your cloud platform and then performing your transforms. So now this enables me more freedom in how I perform these transforms. I can perform these back in Snowflake using SQL very quickly in here to aggregate, filter, add additional columns, flagging, everything like that. But there is some basic level of SQL knowledge to be required in here. But I can have the ability now to transform this very quickly and output this as or save this as a view, acting as a data source in its own. So I'll just kind of move a little bit more now towards a great example of this as well. So actually, sorry, in here, this would be a typical example where I have my data sources in here within Snowflake, and I extract them locally into Alteryx and start to perform my transformations, whether it's filtering, joining and enriching with other data sources, aggregation, and then write this back to Snowflake within here, or output this to my my reporting platform, my consumption layer as well. However, this would not be taking advantage, to take full advantage, to leverage the power and the flexibility of Snowflake. It is useful to utilize Alteryx's in-database tools as well. And so this is where I'm performing, using Alteryx, I can perform my transformations within Snowflake. So rather than moving volumes of data off Snowflake and then back on to Snowflake, I can actually perform these operations within Snowflake to take full advantage of the power and elasticity of the Snowflake platform as well. So switching back now in here, I just have an example of customer segmentation. Okay, I've taken this from the Alteryx Snowflake starter kit, which is very useful. I highly recommend it as well. And within here, what we're looking at is how to perform some initial customer segmentation as well. So I'm using the in-database tool palette up in here to connect to Snowflake directly. Now, within here, I'm extracting everything, or I'm selecting everything within my sample data as well, found in Snowflake on a customer level. And then I'm also selecting everything in my sample orders as well. So I'm still performing after this some best practices where on the customer side, for my customer data set, I'm only selecting the fields that I require as well. So slightly reducing my compute load as well. So here I'm just looking at my customer key, my name, address, some details of my customers as well. So on the orders side now, I'm starting to summarize these just by customer as well. So I'm just trying to segment my customer base by total spend and orders, and the total average of their orders as well. So I can very quickly perform my aggregations within here as well, using the in-database summarize tool, which is the in-database equivalent. So I can really just start to bring this down to a smaller, more concentrated, aggregated level in here, and then joining the two together as well. So this is a very small amount of data, but these operations will perform very well with very large amounts of data as well. So I'm combining them now, performing the join within here as well. So I could write this in SQL, but I can very quickly leverage the graphic interface of Alteryx to drop down one of my join in DB tools. And then from there, again, I don't necessarily need two fields of the customer key. It's been duplicated as part of the join. So I'll drop that down even further. I'll drop that field. And then now I've prepared my aggregated view of my customer base and orders. I'm going to stream this locally. Okay, so now I'll be moving a smaller amount of data off Snowflake to within Alteryx Designer as well. So this is really in here as I start to stream the data out as well. So, so now with the data here locally, I can then use my my other data preparation tools to start to perform some actual segmentation and add additional features to my data. So from here, we're using the Smart Tile tool as well, and starting to basically bin the customers, either the orders as well, or the average spend, average price as well. And so there's a great tiling method in here where we're nominating a column in here, say the orders column, and we're placing every customer into a bucket based upon either average spend, above average, below, in terms of the number of orders. So this is using standard deviation in here. And the same method again, based upon their average total spend, based upon the value of their products as well. So very, very quickly, I can segment my aggregated data set based upon whichever fields that suit my analysis, that support my analysis. However, after I've applied these features as well, I need to label them as well for consumption. So the tiles numbers in here, I'll start to now actually add the labels. And so for that, I use the formula tool Okay, so we can see in here if it's below average, if it's a lower segment based upon standard deviation, then we'll label them as low, medium, high. So making the feature more usable as well for consumption. Okay, same thing again on the average spend as well, kind of segmenting average spend by low, medium, or high as well. Now, I could write this all in SQL, either on Snowflake as well. It wouldn't be too challenging, but this actually shows off how quickly and easily I can use Alteryx with Snowflake in there to segment and add my labels very quickly. Okay, once I've labeled these, but my customers based upon orders or spend as well, I'll bring them back together again and further reduce my data set for analysis as well. And the join tool in here, I can quickly and easily change my data types as well. So quite quickly and easy through there. I'm changing in some cases to string. I'm dropping fields that are duplicated. Say, for example, I've dropped my tile number, which is how they're initially segmented. Okay, and then I'm writing this now back to Snowflake as well, using the Snowflake bulk loader. Okay, so I've overwritten this table, okay, in there, but it is very quickly possible to perhaps even create an app version of this as well, where I might need to provide this analysis to my end users, and they could write to their own tables or in their own warehouses based upon their requirements as well. So I haven't really kind of touched on the app functionality in here too much, but it's very kind of quick and easy. And then I can see my data back again in my customer segmentation. So I can see my kind of cleansed, where is it in here? My kind of cleansed data, where I've performed my segmentation of my customer base by orders or average spend. So I've added these additional features very, very quickly using Alteryx and then writing them back into Snowflake. So, okay. Yes. So there are some advantages of performing it this way, where I could have brought all my data locally and perform this within using just Alteryx on my own laptop, but I'd be constrained in some cases by the resources available on my laptop. Whereas if I use the in-database tools, I can really start to take full leverage of the cloud data warehouse as well. So in this example, because it's a small data set, I've used a small warehouse, but you can instantly resize your warehouse just to support your queries as well. And so that's possible within Alteryx to use a pre-SQL statement as well. And again, that could be based, you could implement some logic or conditions as well, where you're trying to size your query ahead of time, and then that can, within the workflow, and then you can use that to resize your warehouse to accommodate that as well. So you have a lot of flexibility and power with Alteryx and Snowflake as well. So that was an example of how you can briefly prep and enrich your data using Alteryx and Snowflake as well. But let's start to now have a look at how we can start to cleanse the data and use this to perform some predictive modeling as well. And just before I hop over there, I just wanted to talk very briefly about a typical data science process or the life cycle as well, and how Alteryx and Snowflake fit into this loop, this iteration as well. So typically a business will be a data scientist or engineer, data analyst will be leveraging their business understanding, their domain knowledge. And this is quite critical to clearly define their problem statement. What problem or question are they trying to answer? And how does that fit in with their overall strategy and organization's situation at that time? Translating that problem statement down to KPIs and identifying which variables you need to use is going to guide your data selection within a data source or multiple data sources as well. Then typically after you've framed your question, you have to go out and acquire and collect the data sources that you believe will help you answer those questions as well. So that will tend to be internally as well. But there will be other third-party data sources as well. So there might be something within the Snowflake data marketplace as well. It could be public data sets as well. Scraping websites, calls from APIs. That initial phase is really critical to make sure that you've collected all the data that you believe is going to help you create the answers that you need and help train your models as well. So, and that's where Alteryx really kind of can play a large role, connecting to different data sources, very quickly connecting to APIs. But typically, and more times, and very often, the data will not be in the right shape or structure for your analysis as well. So that's where a lot of data prep is involved. And again, strengths in Alteryx in there. So prepping your data, it might be cleaning, it might be like removing incorrect labels, completing nulls, like filling in nulls, filtering down the data as well, really kind of bringing it down and getting it ready for your analysis as well. Before you begin, it's always a very important step to perform that initial exploratory data analysis, where you really explore your data. You're looking for any outliers, you're getting a feel for different fields and their relationships between, and then that will guide you in your selection, your efforts to create additional features as well. And so the additional features can take on different forms, but you'd also be shaped, guided by your domain knowledge as well. So this might be, for example, averages over time, across different products, deviation, a lot of different statistics, descriptive statistics. But finally, adding those features, enriching your cleansed and prepared data set, you can then this will guide your choice, your selection of models as well for predictional classification. Now, this isn't necessarily a completely sequential step. You might take a loop back and forth, iterating between exploring and preparing the data, creating additional features, realizing that you need to enrich your data further with third data sources, and then performing your modeling, training your hyperparameters, and then realizing you need to add additional features to meet your original requirements as well. And then finally, communicating and visualizing your data for your stakeholders as well. So perhaps you may need to structure the data in a certain way to support your visual presentation as well. So you can move back and forth between all of this as well. So that being said, now over here, just kind of walking you through an example again where we use leverage Snowflake and Alteryx together as well. So in this example in here, we're trying to predict the lifetime value of a customer base. So we're analyzing our existing customer base and then trying to use that data and those insights, our features, to predict the lifetime value of new customers as well. So this time, when I connect to my data set, which is I've preloaded into Snowflake as well, I'm selecting different fields and only the fields that I need. So I'm trying to think ahead of time, only the fields that will support my analysis and also for the modeling as well. I'm adding an additional field to say that this is my current customer base as well. But within here, I could also add, I could resize my warehouse. I could bring in, connect to different views. All the SQL commands, Snowflake SQL commands, I can access and utilize in here as well. So now I'm connecting to my new database as well, and I want to ensure that I have the common fields across as well. and I'll be performing that union now within Snowflake. So I can analyze and inspect, assess my results, and I can see that I've used the right fields. But looking closely, I can see that a little bit of additional data prep is required. So where we have household income stored as a string, perhaps we have in here, we have children. This is a categorical variable, and that I'll need to do some work here to use this in my predictive modeling as well. So I can perform that straight away using the formula tool, the in-database formula tool in here. So now I'm performing my calculations within Snowflake very, very quickly in here. So I'm starting to split apart my original string, okay, and then also performing a data type conversion within here as well. For my categorical variable as well, whether or not my customers have children between 0 and 18 as well, I'm converting this effectively into a Boolean, a binary variable within there as well. Again, I have my mosaic household categorization as well, and I'm just stripping just the first character in there, and then I'm adding a flag as well for mosaic. So starting to do that data cleanup and calculations as well. I can perform this very quickly in here. So again, I can inspect the results. So this loop, this data science loop in here, I can start to see, have I applied this correctly? Have I extracted my lower bound income? And I've added this as an additional field in here. I've converted my categorical variable into a binary variable within here, okay? And my mosaic household grouping, okay, I've taken it up a level now, so the highest kind of category, where I've just taken just the first character within here, okay? So I've also can see in here that I've labeled my data sets as well. So just quite quickly and easily, I've been able to clean that data using Snowflake and Alteryx together. So I don't actually need my original categorical children field as well. So I'm going to just go ahead and drop them as well. So I can go through and very quickly deselect, kind of drop those fields. I can also perform some quick renaming as well. And then after I've completed all my initial data preparation steps as well, I'm going to now transfer this out and stream this locally. So this is now I can go back to using my data preparation tools, my kind of local data preparation tools in here. Okay, so I'll be pivoting this data as well. So because I need to start using this mosaic group in here as well, and it's still a string, okay? And I want to predict lifetime value using these fields, using these variables in here. So I'm going to use one-hot encoding effectively, where I pivot this across, okay? And I can see now every type of mosaic group has become its own field, okay? But I still have a lot of nulls within there as well. And so this is like a classic example of feature engineering. There are different typical techniques. Actually, I have a slide back in here where we talk about feature engineering. Okay, so they say that feature engineering is more of an art because it can be quite lengthy. It's a manual process where you'll add additional features and then assess the impacts upon your model as you train the model as well. And so some typical techniques are where you're performing imputation, perhaps filtering out outliers, binning, as we've seen before in that example with average spend, log transforming as well, the one-hot encoding that I just performed, grouping and scaling as well. And so this section in here with online Kaggle competitions, they say that this is really makes all the difference and propels people to win the online competitions as well. It's quite lengthy and manual. You spend a lot of iterations as well. So any tools and techniques that you can use here to speed up that process and gauge the impact of your additional features is really going to improve the performance of your predictive modeling as well. So kind of heading back here into Alteryx now. So I've switched my my mosaic groups across here, and I have them in different fields, but I still have a lot of nulls, okay, within here, and that's really going to interfere with my modeling as well. So I can use the imputation tool within here, okay, and saying that, basically specifying that anywhere there is a null, okay, replaced with a 0. And I have the power to select each individual field, mosaic field, very quickly and easily within here. Then I can kind of proceed again to my next step in here where I was missing some, you can see in here, some household income, the lower figure in here, I had some nulls as well. So this time imputing these with the most frequent value, the mode as well. So it's very quickly and easily achieved in here. I can also add fields to signify where those imputed values are as well. So perhaps as I'm experimenting with the impact of each feature, I can filter these on and off using adding that field to signify where I've actually performed that imputation. Okay, so again, I'm reducing the number of fields in here, only using the fields that I believe I need to complete my analysis as well. And then I'm feeding my prepared data into my predictive model. So for this in here, we're using the random forest package as well. So we're targeting total spend, and we're including these variables in here. So I have some control. I've got my mosaic groups now split out. I might decide that I want to look at additional fields in mosaic groups within there as well, and I'd run several iterations of this to assess, evaluate my accuracy as well. But after I've trained this model using just my current database, current customer base as well, I can inspect the report of the model. Okay, down here, and I can look at the percentage error as I produced larger numbers of trees. But of most interest to me at the moment is this variable importance plot. So how important were particular fields, variables for this modeling as well? So we can see here that the estimated household income lower bound has a very high importance as well. So I can use this to guide my feature engineering as well. And also when I enrich this with additional data sources, I can start to assess the impact of different variables as well. So going through that process quite quickly to iterate and really improve the performance of my model as well. It's a very useful ability. So now I've completed my model and I'm satisfied that it's reaching a kind of higher level of accuracy. I can then take that model and the model object and then apply it to my new customer database as well. With my new customers coming out here, I can apply my trained model in here, and I have my predicted spend now on my new customer database in here. So performing that predictive modeling using the predictive tools in Alteryx is very, very useful. And I've prepped my data very quickly, cleansed it in database using the power and performance of Snowflake within here. And then finally, I can write this back or kind of rename my fields, change data types, and kind of write that straight back into Snowflake now as well. So I have that back in here, my customer segmentation. Yeah. Yeah. So, sorry, my predictive model in here. Okay, so we can see I've written this straight back in. So from here, I could quite a few options as well. I might connect Power BI or Tableau, have a live connection to this particular predictive model in here, and I could use Alteryx Server to automate this workflow and to perform this, to retrain the model based upon when new data arrives as well. So performing that continual training, continual output, writing back into Snowflake, using Snowflake to prep all the data as well. It's very, very useful. So this is quite a small example, but I hope this really helps kind of show how you can use the power of Snowflake and also the power of Alteryx as well for data prep within here. Within here, I've kind of covered manual feature engineering as well. There are some really very interesting open source libraries as well that are supported by Alteryx. One in particular called Feature Tools as well, which can automate this process even further for automated feature engineering. As well, where you specify the relationship between your data sets as well. So if you're here, we've only used, in this example, we've only used a single table, but your data might live in several tables within Snowflake as well. So you can use feature tools to specify the relationships and the depth of the features that you generate as well, and then assess the importance of those generated variables in your predictive model. So it's quite an interesting, it's used technology, or the concept is called deep feature synthesis as well. And I'd be happy to run another webinar, or if there's some interest in there as well. So hopefully you found this useful and interesting to help you how to speed up your feature engineering and your data science efforts using Alteryx and Snowflake as well. I'd be more than happy to answer any of your questions or provide an in-person demo. I've been using the 30-day trial on Snowflake. There's also a 2-week trial of Alteryx Designer as well. And I've been using the Snowflake Starter Kit as well. So please let me know if you have any questions. But I'd like to thank you very much for tuning in to the webinar. And please tune back in again. We run a whole series of webinars covering different topics across business intelligence, data science, data engineering as well. So thank you very much.